Okay, so guys, what we've talked about, or what we talked about yesterday was passive transport, right? Talked about passive transport. And we said that passive transport, well, first of all, let me backtrack. We also said that the cell membrane has how many layers? Two. It has 2 layers. And this isn't quite proportional, keep in mind. All right? And so I'm going to zoom in on this, and I'm going to do a fine point pen here. And remember what we looked at was that on each side of it, something looks like that, right, everybody? And then objects, particles, can find their way in between those things, right? And those are the little holes that we've been talking about. So yesterday we took that to another level. Okay? And molecules go from high concentration to low concentration through that, right? But we said not every particle can get in that way, right? We also said that if there's large particles like this, the membrane would just absorb them and allow them to go through the membrane, right? So in and out. And we call that endocytosis and exocytosis. To the new layer, to the new topic, was we talked about yesterday having this. Does anybody remember what that represents? Shout it out.
Is it endo something?
Them 2 yellow ones, the protein.
The proteins, right, Seth? The protein passageway, that's right. Everybody remember that now? Yep, so these are proteins, and we call those protein passageways. Okay, right, everybody's golden with this? This is yesterday. I don't know if yesterday's video went through or not. But an object larger, hey, you guys can't be writing all this stuff down. We had it yesterday, didn't you? Watch. An object that's really small goes through the membrane here, right, everybody? Mm-hmm. An object that's really big goes through the membrane like this. But some are sort of medium-sized. And these medium-sized ones, we said went through the protein passageway. Everybody, right? Mm-hmm. And they're allowed to, or they're able to fit through there and pass right on through that protein passageway. Okay, and we call that passive transport. Kind of the definition that we said is that molecules that are medium-sized travel from high to low concentration using no energy and travel through the protein passageway. Okay? Are you good? You guys good with this? All right. So there's our review from yesterday, the big review. All right. Today's study Today's study is going to be what? You remember I had you guys research it yesterday. Shout it out. Active transport. Okay, so first of all, what we need to do is we need to talk about the difference between the words active and passive. Active and passive. All right, so instead of talking about it, what I'm going to have you guys do is I'm going to have you act it. So you're going to act out what you think active is. Got it? And then you're going to act passive. So everybody, right, if you don't know what you're doing, look around, see if you can pick up on what other people are doing. And then, so we'll just do this. So I want you guys to show me what active looks like. Okay, passive. Active. Alexis, gotta be moving. Ryan, gotta be moving, dude. Passive. Okay, now let's talk about using energy. Lots of energy. Lots of energy. How about no energy? Using energy. Passive. Active. Using no energy. Active. Passive. Active. Passive. Active. Passive. Active. Passive. Active. Passive. Passive. Okay, I can't do it any faster than that. Okay.
Okay, I'm tired.
So then, going back to active transport and passive transport. So they both have this word in it. Transport, right? So if they both have that word in it, and the only difference is the active or passive, talk in your groups about what do you think the difference between those are. Talk, and I'll give you, I'm timing it here. 30 seconds, go. Here, talk to these guys. Just about done. All right, and back to your seats. So, does anybody have a guess? Or what you guys discussed as far as this stuff goes? Trace.
Passive is like moving a little bit, like moving slower,
Okay.
and active is like moving a lot more fast.
So you're saying the speed of the way that molecules go in and out. Okay, all right. I like that idea. I like it.
Like aggressive.
Go ahead.
Like, inconsensus is like when you're asleep and the molecules are going slow. And when you're running, it goes faster because you're going faster.
Okay, so you're both saying that the difference between passive transport and active transport is the speed at which the molecules go in and out. I like it. That's not it. It's a good guess, but that's not what it is. Ian.
Passive is other stuff forcing it to move.
Oh, you mean so the molecules are being forced to move. In all the other things we've talked about so far, the molecules are moving on their own, aren't they? So what you're saying, Ian, is that these molecules in active transport are being forced to move. And because they're being forced, they move. What about the energy connection? I haven't told you that yet, have I? Active, well, we've said it, but we've kind of hinted towards it. Active meaning it uses energy, right? So let me go ahead and set up another cell. Okay, here we go. All right. All right, there's our cell that we're working on now. Where are the molecules going to go? Hey, remember what a high concentration looks like. High is like this. Throughout the whole thing, this would be low. Everybody follow me on that?
Yeah.
All right. So if this bottom one is active transport, then it's using energy, and you think what, Ian?
That other molecules are forcing them to go out.
So you think they're forcing the molecules to go from high to low through the membrane. That's a great guess. And you have some good ideas here, but you're not quite there. Anybody have a different guess? Caden?
They move depending on how much energy you use.
Well, you're right. They use energy here. Here's the key. In all other situations, the molecules go from high to low, except for this situation. Except for this situation. Okay, in this case, the molecules are going from low concentration to high concentration. And you're like, okay, well, think about that. That's like swimming or canoeing up a stream, isn't it? The normal flow is out. And yet those molecules are going in. What takes more energy, to go upstream or downstream? Go upstream, right? Into the flow of water. And that's what's happening here. This protein, these proteins here and here, are actually using ATP, which is the cell's energy, to make that happen. I see a lot of you guys writing this down. That's good. So I'll say this again. Okay? I'll say this again. The molecules that are medium-sized are going through a protein passageway from a low concentration outside to a high concentration inside. And because of that, it requires them to use ATP energy. Last hour, the kids said, hey, Mr. Lundquist, we understand the idea, but why? But why are these molecules doing this? Well, it's because the cell is preparing for something. It might be preparing for cell splitting, cell division. It might be preparing, they know that there's going to be a heavy workload coming. For some reason, they get signals. So they're preparing for something to occur. Everybody with me on that? Maybe they want extra oxygen to prepare. Maybe they want to build extra ATP, so they need more whatever molecule in there. Does that make sense, guys? Mm-hmm. So they're preparing for it, and sometimes when they need to move molecules opposite direction, they use energy. Everybody cool with that?
Yeah.
So it's the same as passive transport in the idea that molecules are going through a protein, right? That's the transport part. Passive meaning no energy and going with the normal flow. Active meaning against the normal flow and needing ATP energy. Are we good to go? All right, I'm stop that baby.